This video is on Year 8 factorisation, and it's just a quick little recap because we're about to move to, I guess, a much more advanced way of factorising, and that way is something you'll see until you get to Year 12. So I think it's quite important that your Year 8 factorisation is quite good and you understand the difference between what you're about to start doing and what you should already know. So in Year 8, the factorisation looks a certain way. You will be pulling out one term, or the highest common factor, of a series of terms. So all your answers will have this look where you've got the highest common factor, or the HCF out the front of the bracket, and then the rest of the expression inside. So all three of these questions will be done in a very similar way. So the important thing not to do, I guess, or the important thing to get right is you must get the highest common factor correct. It must be the largest factor, or you'll find that your teacher's written on your paper somewhere fully factorised or not fully factorised. So what you want to do is first look at the numerical parts, get that right, and then you can look at the algebraic parts. So let's use two different colours, get my algebra right. So if I look at the yellow numerical parts, the highest common factor of 8 and 12, or minus 12, would be the 4. And then if I look at the x and the x squared, well, it's always the smaller or the lower amount that you can take out. So the lower power is x to the power of 1, so that's all I can take out. Because if I take the x squared, then how am I going to get just a single x term once I've got the x squared? I won't be able to get that x there. So you have to go for the lower power. And then I've got a y squared and a y. So once again, I'm going to go for the lower power. I'm going to remind myself there's a multiplication sign there. And now I'm going to try and work out, what do I multiply 4xy by to get this first term here? Well, I certainly needed 2 to get this 8. And I've already got the x out the front, so that's done. And I need a y squared. Well, I've only got a y here, just over here. So that means I need one more y to get the y squared. I've got a negative here, so I'll need a minus joining the two terms. And 4 times 3 will give me this 12. So I've got the 12 now. I've got a single x here, and I need an x squared. So I'll pick up another x. And I only need y, which is already out the front here. So that means I'm done. And you can always do, it's very important that you take that term and you do a quick mental check that do these two terms multiply to give that term, and do these two terms multiply to give your second term here before you move on. All right, next question is much harder because I think a lot of students will get the highest common factor incorrect. So please use your calculator if you have to, just making sure that you've picked the largest number that goes into minus 14, minus 56, and minus 28. One of the errors that students are going to make is that all the terms are negative. And if all the terms are negative, you must take a minus out. That is a standard rule of factorising, is that if all the terms are negative, every single one, then the negative must come out. So if you've been playing around on your calculator, you could always pause the video to try and find the highest common factor of 14, 56, and 28. Pause it if you want to, and then you can unpause and check if you're correct. But you should have gotten 14. I think a lot of students would think it is 7. So you really have to be extra careful with that. Now let's highlight our common letters here. We've got m squared and m squared, and like I said before, you must take the lower power. So I'm only going to take the m, and then I'm going to go and look at the other. I love these colors. We've got n, and n squared. So once again, we're going for the lower. So we're going to take the n out. I'm going to remind myself this multiplication. Luckily, I've already got the minus 14 out the front already here. So that means I need no coefficient there. Oh, and I even have the m, and I have the n. So, well, if it's the same term, if this term and my term outside are the same, well, I must just multiply by 1 to keep it the same. Now, minus 14, how many times does that go into 56? Well, firstly, the negative is already outside the bracket, and so that means I must need a positive to keep it negative. If I put a minus there, then the 56 will become positive. So be careful with your signs. 14 lots of 4 will make 56. I've got an m squared, so I've only got one m over here, so it means I'll need another m to make m squared, and all I want is an n, which is already out the front, so I'll leave the n alone. Last one, once again, we've got a minus 28, so I must need a plus, because the negative's already out the front, so I've got to keep it negative, put a plus down. 14 times 2 is 28, m, well, I need m squared, so I'll pop another m down. M times m is m squared. And now I need an n squared, and only 1 is out the front, so I need n over here as well to make n squared. So you can see that's definitely a harder example than the first one, and probably lots of room for mistakes. So be really careful, go slowly, and definitely get your highest common factor correct. All right, this is the last kind of question that I think is definitely quite hard in Year 8 especially, and that's where we have a highest common factor, but it doesn't look like a highest common factor. In fact, a lot of students would want to expand the brackets for this question, but no, these questions are all about factorizing. And what I want you to see is that I can actually make this question look very similar. I'm going to write it as ZA minus 3A, and I want you to notice that my A is really this purple expression, or lilac, or whatever color you want to call it. And I want you to notice that, can you see that it's common to both the terms? I've got 2x minus y here, and I've got 2x minus y, and they're joined to the other term, or to the other pronumeral or number, by multiplication. And what that means is, here you'd happily tell me, we'll take out the a. When we take out the a, we would get z minus 3. Well, in this case, instead of taking out the a, I need to take out the 2x minus y. Okay, it is common. It is the highest common factor of both terms, and it is common to both of them. So just like all the other examples, you take whatever is common out the front. And then you think, well, what do I times this expression by out the front to get the very first term? Well, here's my first term, and the only thing I'm missing is this z. So I'm going to multiply by z, and then I've done the first term. And then to get my second expression over here, well, this has gone out the front, so what I need is to multiply by 3. And I've got to get a minus 3, sorry. So I'm going to put a minus down to keep the second expression negative, and then I'm going to put the 3 down as well. And you can do just a little visual check. Get rid of all that color. Let's do a little visual check and just make sure it's the same thing. Z times this expression, yep, that's z lots of 2x minus y. And then minus 3 times that expression, yes, there it is, minus 3 lots of 2x minus y. So it is the same expression, but just factorized. All right, I hope that makes sense. That is, I think, hopefully the full picture of Year 8 factorization, but definitely at a harder level, like ready to begin Year 9 factorization.